Lesson 3.6, Proportional and Non-Proportional Relationships. Our essential question today is how do you identify if a graph or equation is proportional? So we have two new vocabulary words. The first one is proportional and the second one is non-proportional. When a relationship is proportional, the graph is going to be a line through the origin. So not only does it have a constant rate of change, but it has to go through 0, 0. So an example would be that. So it has to go through the origin. Non-proportional then, with the prefix non in front of it, you can probably figure out what that means. The graph is a line that does not go through the origin. So it's still linear, it's still a line. It just does not go through 0, 0. So it has a different y-intercept. So it could be like this, does not go through the origin. Now our first two examples, we have tables and we're going to take things step by step and we're going to have to graph the data. So this table shows the number of miles traveled for each hour driven. Graph the data, part A. Write an equation to describe the relationship for part B. Find the number of miles driven in 8 hours for part C. And then last, part D asks, is this function proportional? So I am going to graph this data. Remember that our X and Y axis, our X axis is where we will display our input or independent variable. So our independent variable is going to be time. So I'm going to start with 1, 2, 3, and 4 and label hours for my time. And then on the y-axis I need miles because miles are the dependent variable. The number of miles you've driven depends on how many hours you've been driving. The miles go up by 50 each time, so that works for me. I can go by 50s. Okay, now if I graph my data, 1, 50, 2, 100, 3, 150, and 4, 200. Looks about like that. I can connect it because there's always something in between 1 hour and 2 hours, or 2 and 3, 3 and 4, so it makes sense. They don't need to be discrete dots. So here's my graph. Write an equation to describe the relationship. Well, I would say the number of miles, I can use M for miles, and the number of hours, maybe I use H for hours. So it looks to me like the number of miles equals 50 times the number of hours. If you look at our graph, the slope of our line, I go up 50 over 1. Up 50 over 1. So the slope would be 50 over 1, or the rate of change, 50 over 1. So I put the slope right here in front of my variable h. So I've got my dependent variable m equals my rate of change, 50, times my independent variable h. Now, find the number of miles driven in 8 hours. Well, oops, this was part B. Part A was my graph. Sorry about that. This is part B. Okay, so then part C. In 8 hours, if I plug in 8 where the H is, 50 times 8 is 400. So 400 miles. And then part D, is this proportional? Well, it's a line and it goes through the origin, 0, 0. So yes, it is proportional. Okay, our second example. This table shows the cost for a certain number of t-shirts. So it says graph the data. Okay, so I've got my X and Y variables here. So X-axis, number of t-shirts, is our independent variable. And then our dependent variable is the cost. So the cost depends on the number of t-shirts, that makes sense. So 0, 2, 4, 6, and 8 for t-shirts. And then the cost, 20, 30, 40, 50. So I need to go by tens. So 10, 20, 30, 40, 50. So this is cost in dollars. Okay, so I can graph my data. 2 is 20, 4 is 30, 6 is 40, and 8 is 50. So if I connect these, it is not going to go through 0, 0. It's not going to go through 0, 0. Okay, so graph the data. So we've got our graph. Part B, write an equation. Well, from one point to the next, my rise over run, I'm going up 10, and I'm going over 2. So my rate of change, it's going up $10 for every 2 t-shirts. So that's 5 for my rate of change. So I've got my independent variable, cost, so I can use C equals. My rate of change is 5, and t-shirts I can use T, plus I need to figure out my intercept. Now, because I graphed this, my line isn't looking the greatest. It looks like it's about 10, so I think it's 10. If I go to my table, I'm wondering if my table can help me. This rate of change, you see how Y is going up 10 each time? That would indicate that if I kept that pattern going and I worked backwards, it makes sense that 50, 40, 30, 20, and then 10 would come before 20. And then 8, 6, 4, 2, these are all 2 away, so that would take me to 0. So 0, 10. So 10 is my intercept. If you're graphing on graph paper, it's a lot easier to figure out than on the smart board like this. Okay, find the cost for 20 t-shirts. So now I need to plug in 20 and solve it. Well, 5 times 20 is 100 plus 10, so the cost would be $110. And then part D, is this proportional? No, it's not proportional. It's a line, but it doesn't go through 0, 0. Okay, now we have some review. We need to write an equation in function notation. So f of x equals mx plus b, where we have our slope and our intercept. And then our new information is to say whether or not it is proportional. So the slope of this line, I need 2 good points to use. My slope looks like I'm going up 1 over 2. So f of x equals 1/2 x, because I had to rise 1 and then run 2 to the right. And then my intercept is right here at positive 2, so 1/2 x plus 2. Is this proportional? No, it does not go through the origin, so it's not proportional. Next one, this point looks good to use, and so does this one. So f of x equals, my slope this time is going down 1 over 3. So negative 1/3 x plus this one goes through the origin, so I don't have an intercept. So I don't need to write anything after my x. So yes, this one is proportional. It's a line through 0, 0. Next one. This looks like a good point. And this one. Okay, so f of x equals my slope. I'm going up 3 over 1. 3 divided by 1 is 3. So I can just write my slope as 3. It doesn't have to be a fraction if it can be reduced to a whole number. And then plus my intercept is 4. So no, this one is not proportional. It doesn't go through the origin. Next one. Point here and point here. So f of x equals my slope. Always make sure you're starting at the point on the left. So I'm going to have to go down 3 over 2. So that makes my slope negative 3 halves. And then my intercept is positive 4. So no, this is not proportional. Does not go through the origin. Okay, this last slide has some graphs and some equations. Remember, the ones that are proportional have to be lines through the origin. So these two are proportional, these two are not. And then from the equation, remember, if they're proportional, they're not going to have anything after the x. They don't have an intercept that you need to write because it goes through 0. So you don't have to write plus 0. All of these that I'm clicking and dragging have intercepts that are different from 0. So positive 2, negative 7, negative 1, and then the graphs, this one's 4, and so is this one. So that's the key. The graph has to go through the origin, it has to be a line, and the equation does not have a y-intercept written because it's 0. You should be able to write a summary now, answering our essential question, and make sure that you address both the graph and the equation, how you can figure out if something is proportional. And then you can work on your homework.